This is just another look at writing function rules. A function rule is the same thing as an equation given various pieces of information. So we're going to start with given a graph. So starting with example 1, it asks for rate of change. So the rate of change, remember, is just what is the slope. So you should definitely notice this slope is positive because it's going up from left to right. So that's positive. We already know that. Rate of change, we use rise over run to represent slope. So I need to know what is the rise and what is the run. And for some students, this is tricky, right? Because you're counting spaces. So what we need is 2 pretty points. That's nice because our graph gave us 2 pretty points. We have a point right here on the y-intercept. That y-intercept is going to be really important because it asks us for our y-intercept, and then they give us this point right here. So the rise over the run, really important that you can count this. So from here, we're going to go up. Up is positive. Up. 1, 2, 3, 4. So we go up 4. So our rise is 4. So I'm going to zoom back out so I can write my rise over here is 4 over my run. So let me get a different color. My run is to the right, which is also positive, 1, 2. So 4 over 2, when I simplify, 4 divided by 2, that is just positive 2. 4 divided by 2 is 2. So that means I should also be able to go up 2 over 1, because to make that a fraction, I would put it over 1 and still be on the line. So let's check that. If I go up 1, 2, over 1, still on the line. Up 1, 2, over 1, still on the line. Up 1, 2, over 1, still on the line. I can also go down 2 and left 1. Remember that down is negative, so down 2 is negative, and then left 1 is negative. I'm still on the line right there. See that? A negative 2 over a negative 1 is still a positive 2 because a negative divided by a negative is a positive. So all of that to say our rate of change is 2. So our rate of change is 2. Our y-intercept, one more thing about rate of change. If it's not a fraction, like the number 2, we can just write as a whole number. We don't have to put it over 1. It's automatically understood that this rate of change is going to be 2 over 1. So just really clear that up, that this, yes, it's 2 over 1, but we don't have to write the over 1 because it doesn't simplify, or it simplifies to just 2. Okay? Our y-intercept is the point where the graph crosses the y-axis. So that y-intercept was right here. They gave that to us, so that point, again, is always where x is 0. It's negative because it's below the x-axis, so negative 1, 2, 3. So 0, negative 3 is the y-intercept. 0, negative 3. So to put that into an equation, our equation, again, is in the form y equals mx plus b. So I'm going to write that over here. Y equals mx plus b. Remember, our m is our slope, or our rate of change, so the 2 right here. And the b is the y-intercept, so negative 3 is the b right here. All we do is then plug those two numbers in. So our equation is going to be y equals, our m is 2x. Our b, we could put plus negative 3. I'm just going to write minus 3. Plus, negative, and minus are the same thing. So I try not to put double signs. So if my b is negative, I'm just going to put minus. So one way I could check that just very quickly is go to my calculator and type that in. Y equals 2x minus 3, and it should look like that picture right there. So minus all the writing, obviously. So if I go to a new document, no, I don't want to save, add a graph. Remember, f of x and y are the same thing. My equation was 2x minus 3. Push enter. You should notice it looks just like that. I can even trace. So menu, trace, graph trace. There's that point, 0, negative 3. Here's another point right here at 2, 1. So I could go to 2, enter. There it is at 2, 1. You could even check this point right here at 4, 5 and see if you agree with that. 4, 5. There it is. So just double check using your calculator. No harm in that. All right, example 2. So same thing, what's your rate of change, what's your y-intercept, and then what is the equation? So I'm going to start this time with my y-intercept, again, just because I think it's the most obvious point. The y-intercept is where the graph is crossing the y-axis, and that is right here at that point that I'm coloring in purple. So that point is 0, 3, right? The y-intercept is always where x is 0. So 0, 3. Our rate of change this time is negative. This line is going down, right? From left to right, it's going down, so it is negative. So I already know my rise over my run is going to be negative. So I'm going to write that over here. Rise over run equals, I already know I have to get a negative answer. I need 2 pretty points, and they gave me 2 pretty points. So I'm going to use those. So I'm going to start right here at 0, 3. I'm going to go down, which is what makes it negative. 1, 2, 3, 4. So down 4 is negative 4 over divided by, and then I'm going to go right, which is positive 1, 2, 3, 4. So right is positive. So negative 4 it was my down 4 divided by positive 4 was right 4. Negative 4 divided by positive 4 is just negative 1. So my slope should equal negative 1. Again, that's negative 1 over 1. So I should be able to go from here, down 1, right 1, still on the line, down 1, right 1, still on the line, down 1, right 1, down 1, right 1. You can also go up and left. The up is positive, but then the left is negative, so that's what makes it a negative 1. So our rate of change is just negative 1. Okay? So our linear equation, again, in y equals mx plus b. So writing this in y equals mx plus b. It's just y equals, our m is negative 1, x plus our b this time is positive 3. Okay? Another way that could be written is without the negative 1. It could just be y equals negative x plus 3. So that's a negative right there. Anytime there's not a number in front of that variable, remember that that's an understood one. So y equals negative x plus 3. Again, you can check that in your calculator. So I could go back to my calculator, push tab. I would go up to F1, delete this one all the way to the equal sign. Remember, if I accidentally delete the equal, just push escape. So negative 1x plus 3. Enter. There it is. I'm going to show you if I push tab and I just type in the other one, the negative x plus 3. So negative x plus 3. Enter. Notice that's the exact same line. I put the red line right on top of the blue line. They're the same line. You can even go to the table. So to get to the table again, Control T, and you can see, let me spread this out just a little bit. You can see that these, maybe not, you can see that these tables are the exact same. So right here where I have x is 1, the first one is 2, the second one is also 2. So right there 2. 2, 1, 1, 3, 0, 0, 4, negative 1, negative 1. So they're the exact same. Okay. So just a way that you can see that those are the exact same. Okay. All right, let's look at the next one. Now, given a table, so given a table I think is a little bit more difficult. I can't just count my coordinates. I actually have to do a little bit more math here. So the other thing is you have to find your y-intercept. So just remember your y-intercept is always where x is 0. So 0, y. So notice that's not in my table, but I left an open spot there. So we need to figure out what is that. So when x is 0, what is y, or f of x? Okay. All right, let's find our rate of change first. So rate of change, again, is rise over run. So I'm going to put rise over run. Okay. Or change in y over change in x. I'm going to write that too. Change in y divided by change in x. Those triangles mean change. All right, so if I'm looking at my table, I only need 2 points. So I can use these 2 points, I can use these 2 points, or I could use the first point and the last point. It doesn't matter. If it's a linear equation, I can use any 2. I'll just go with these 2 because these are the closest ones. So I'm looking for this change from 6 to 18. Hopefully you know it's a change of positive 12. So my change in y is 12 over, divided by, my change in x from 1 to 3 is plus 2, right? It's an increase of 2, so over 2. So 12 divided by 2 is just 6. So my rate of change is 6. Let's do that again just to make sure we understand. So my change in y from here, 18 to 30, would also be plus 12. So my change in y is 12 divided by or over 3 to 5 would be plus 2. So 6 divided by 12, or sorry, 12 divided by 2 is 6. So our change in y over change in x, or our rate of change or slope, is 6. Okay. Our y-intercept is where x is 0. So this time we have to go backwards. So if I know that going forward, my table is increasing by 6, okay, in this table, because I went up by 2, it actually went up by 12. But if I know that for every 1, so halfway between here, at 2, it would have only gone up 6. So this would have been 12. Okay, at 4, it would have gone up 6, which would have been 24. Okay, so if I know going to the right, my table is increasing by 6, I know that because my slope is 6, then going backwards, instead of going up by 6, I'm just going to go down by 6. And I know that because I'm going from 1 to 0, so that's just back 1. So back 1, I would subtract 6. So if I subtract 6 from 6, that would just be 0. So my y-intercept is 0, 0. Again, I understand that that might be confusing, but I promise we'll cover this a lot more. And we're going to use our calculator to check it. So if my y-intercept is 0, my slope is 6, I can now write my equation. So in y equals mx plus b again, y equals mx plus b, that's just going to be y equals, my m was my slope, is 6x plus b. My b is the y value of the y-intercept, that's 0. So I don't really even have to put that. So I could put y equals 6x plus 0, but normally we would just write that as y equals 6x. Okay. So if I just want to check this really quickly, especially because this y-intercept was a little bit tricky, I could just go back to my calculator and I could type in. So I'm going to get rid of this table, Control T to get rid of it, Tab. It went to F3 because I already have something in F2 and F1. So I'm going to delete F2, Enter, and I'm going to push Tab again, go back up to F1. I'm going to delete that, and I'm going to type in 6x, Enter. So that's what the line would look like. I can trace to get to these points, or I could just use the table. So I'm going to do the table because it's a little bit faster. So Control T. So at 1, 6, that was given to me. I didn't have 2, but I did write that in right here, 2, 12. Then 3 would be 18. That was given to me. At 4, I said 24. That matches. At 5, 30. The most important part, though, is going to be the 0. So to get to 0, I'm going to go to the x side and push up. So it's 0. There it is, 0, 0. So that's really important that that matches what I decided on my table. Okay. All right. Let's go to example 4. So same thing. We have a table, and we need to fill in the rest. So again, notice on my x, this is really important. I went from 1 to 3. So that's an increase of 2, and then 3 to 6 is an increase of 3. So this table is not consistent about how much it's skipping. So it's going to be really important that you get this y-intercept correct. Okay. All right, so rate of change, again, is the change in y divided by the change in x. So you can use any 2 points. So if I'm using 2 points and I have to choose a negative, I will do that. But what I see is that these are both positive. These are the ones I'm going to choose. I can count a lot better whenever it's 2 positives than when I have a negative and a positive. Okay, so I need to know, what is this change in y from 3 to 9? So from 3 to 9 is a change of plus 6. So my change in y is 6 over or divided by my change in x for that same place. So from 3 to 6 on the x is a change of plus 3. So my change in x is 3. So 6 divided by 3 is just 2, right? 6 divided by 3 is 2. So every time x increases by 1, y is increasing by 2. So the change in y is 2, the change in x is 1. So that's going forward. So now I need to go backwards to get back to 0. So going forward, it's plus 2. Going backward, it's going to be minus 2. It's going to be the opposite. So going backwards, 1 this way would put me at 0. That's what I want. I have to go backwards this way. Instead of plus 2, it's going to be minus 2. So negative 1 minus 2 would be negative 3. Okay, so our rate of change was 2. Our y-intercept is going to be 0, negative 3. All right, so my linear equation, again, is in y equals mx plus b. So I'm going to write that, y equals mx plus b. My m is my slope, which is 2. So y equals 2x plus b. My b is minus 3. So instead of putting plus negative, I'm just going to put minus 3. So 2x minus 3. So I'm just going to double check, make sure that my math is right by using my calculator to check the table. So I'm going to go back to my calculator, Control T to get rid of the table, Tab, go back up to F1, delete this to the equal sign, 2x minus 3, enter. So there's what the line would look like. So now I just want to double check, do I have the right point? So I should have 0, negative 3, 1, negative 1, 3, 3, and 6, 9. So 0, actually I need to trace, I forgot to trace. So menu, trace, graph trace. Now we want to trace to 0, enter, negative 3, that's what I have. 1, enter, negative 1, 3, enter, 3, 6, enter, that works too. Again, I could have done that from the table, so Control T to get the table would have done the same thing. All right, we're going to do the word problems together in class, and then we will put this in our journal.